This is one of my favorite chapters, and I'll talk more about it in the Zoom lecture. When you look at the clouds in the sky, they are made of gases. When you look here on the left on the bottom, this man, what this is, it is a scrubber that scrubs out sulfur dioxide, because in air, sulfur dioxide can lead to HOSO4, which is acid rain. So again, that's why that one is important. Then, of course, we have carbon dioxide. Again, we'll speak in the Zoom lecture. We'll also speak more about blood gas measurements. That's the oxygenation, which has been really important in the time that we've been handling our pandemic. We could talk about natural gas pipelines, the methane that is piped underground all over the United States. We could also talk about something that really hit me. When my daughter was a grad student at Caltech, we would go out and hike outside of Pasadena. And standing on the mountains, this is what downtown LA looked like. And this was the inversion layer. I was just mesmerized by what I saw, because back east here we don't have it, and this is before the California wilds. Finally, our assigned homework problem as usual, and now let's really get to the gist of this chapter, okay? If we're going to talk about the characteristic of gases, the air you're breathing right now is a mixture. 78% nitrogen, 21% oxygen, the number of other gases. There's 2 great PBS DVDs that talk about how did they learn these things, all right? Gases can be monoatomic. Let's choose the helium for your party balloons. They can be diatomic. Let's choose the nitrogen and the oxygen you're breathing. And let's choose polyatomic. That would be steam or water vapor. Now, know that a substance can exist in all 3 states of matter under what I'll call the right conditions. You know, ice forms below 0 degrees, water is from 0 to 100, and water vapor or steam is over 100 degrees centigrade. Now, can sodium exist in the gas state? Yes, because remember, we said under the right conditions, substances can be any of those 3 phases. The thing that has always struck me when I teach this is that a gas can behave as if other molecules were not present. That is not to say it's non-reactive, because sometimes it will undergo chemistry, but its general behavior, like when we talk about oxygen and nitrogen we're breathing, they act as if there's nothing else present, all right? In terms of the volume, they're going to be the same as the container. And I grouped these 2 together because if we were to take the air in our rooms, it would be 0.1% of the total volume. When I taught the majors, we would do a sample where it'd say, this is the size of our room. We're going to seal the doors. How long can we live in this room based on the oxygen that is present? Because the rest of what volume is in a gas is really empty space. You'll see that when we talk about kinetic molecular theory in this chapter. And finally, gases can mix in any proportion. And what they will do is they're going to form a homogeneous mixture. Notice a lot of the terminology that we had all the way back in chapter 1. You needed that in order to go deeper into the other topics we cover. So, as we begin this chapter, the key points we're going to deal with are the ideal gas law. You need to learn how to do the calculations for the applications. We're going to talk about partial pressures because you can't weigh a gas like we weigh a solid or a liquid. And we're going to apply that to gas mixtures. Finally, touching very lightly on kinetic molecular theory, and finishing up, which what I think is really important, is what do real gases do? Real gases have volume, real gases have intermolecular forces, and those are covered in chapter 11. So again, this is an easy chapter. It's also a very applicable chapter.